Uh, Dear participants, speakers, and the panelists, I am Mr. Joshi, the moderator of today's webcast. I warmly welcome you to today's webcast session on Rainstrom design flood prediction for Angaj Basin of Nepal by modified PCJ 1996 runoff model, organized by the Institute for Integrated Hydro Environment Research, IIHR. We are profoundly honored by your presence and delighted to introduce Dr. Prem Chandra Jha as the speaker for this session. Dr. Prem Chandra Jha, widely known by his initial PCJ, is a distinguished hydrologist. He earned his doctoral degree from Moscow Technical University, Russia in 1996, specializing in hydraulics and engineering hydrology. Currently, he serves as a professor at the Institute of Engineering, Pulso campus, Tribhuvan University. He is also a chairman of Civil Engineering Subject Committee at the same institution. Dr. PCJ has extensive experience in teaching, research, and consultancy within the field of water resources engineering. He is celebrated for his PCJ 1996 runoff model, which estimates design floods in Angaj River Basin. Today, he will present on the modified version of this runoff model. So before we delve into the program, I would like to provide a brief overview of IIHR. Sorry. Established in 2021, IIHR was formed by merging like-minded researchers, including young and enthusiastic individuals from field of water resources engineering, many of whom studied at prestigious universities in China and India. As a collective of learners, IIHR have successfully conducted training on numerical modeling software such as HECRAS and Dell 3D. In addition to that, we have also conducted um, training on hydrological data management using Python and SQLite. Together, IIHR founders have a total publication of 50, which have been cited 500 times. So, without any hesitation, I welcome Professor Dr. Prem Chandra Jha for this session, and let's start it with it.
Okay, thank you, sir. I think maybe first we have to introduce, I think 5 minutes or 6 minutes it will take. So let us introduce first who are presenting here, yeah, presented at this time, and how we want to proceed. First, we want to proceed.
Yes, sir. So to discretize this session, this webcast, we will have 4 different sessions. Like first, you will give a presentation, then we will have a panel discussion, then Q&A from the audience, and then we'll have a closing session. So this is the first session of this webcast.
Okay, then I have to go share the screen, yeah? I have to go for share the screen.
So you could share your slide. Yeah, we are getting your slide, sir. Yeah.
Okay.
Okay.
Okay, thank you again, sir, and IIHR for giving me this opportunity. Actually, this dissertation work is very, I think, old because you can see PhD dissertation in 1996 at Moscow Technical University. And I think about 28 years I have been using this methodology for the unconsiderations and as well as for considerations also for the verification of the results. And I think in elective course of watershed management and rehabilitation engineering, I am continuously giving this methodology, introducing this methodology to my students at Pulchok and Gujarat Engineering College and other colleges. So I think most of my students are already have been introduced by this method, but actually many of them can use this method and find some results of flood prediction. But the background and the methodology itself was not explored yet. The first time in 2006, it was explored in guidelines for hydropower projects by DOEP. And there you can find, I will give the address that of guidelines, and you can find the PCJ method. But again, there has not been given all the things because there are so many parameters we have explored in this PhD dissertation. So let me let me go thoroughly for this dissertation first. What was done at 1996, and then I will continue for the modified PCJ. Okay.
Okay.
So first, we have to understand what was the need at that time. Even after 28 years, we say feel the very much need of flood prediction because we have to construct so many hydraulic structures like in hydropower or irrigation or water supply, melancholy, you see. There has been very big problem at intake because of floods, yeah? As well as road construction. So actually, Moscow Technical University has seen that this is Moscow Automobile and Road Construction Institute, and I have completed my master's degree in irrigation and drainage. Then at that time, I was just thinking that if hydrology, so flood prediction or long-term flows, is not accurate, then the structures we want to make will be not long-term sustainable or economical. And that's why at that time I meant to divert myself to hydrology. And I was completed my master degree at Moldova State at Kishinev University. And then I returned to MADI, Moscow Construction Institute, where I have completed my first year language course. So there I found my supervisor who has been working in Nepal at that time, Patlaya to Dhalkebar road. They have worked out all the hydrology and hydraulic subjects. And as most of you were there in field visit in Bagmati project, and you saw that the bridge still the bridge is working. They have made from their experience because at that time there was no hydrological data, but my supervisor at that time collected some rainfall data and have completed his PhD at this institute on the hydrology of Nepal at that time in 1967. 1967. Okay. So actually, I converted myself to work out the methodology of flood prediction because hydrology is very, if you vague, then long-term hydrology and low-flow hydrology, drought hydrology. But we choose at that time with my supervisor the flood, how to predict the flood, and let us say for ungauged basin. Because for gauged basin, it is very easy. You can do frequency analysis and so many things if the data is available. Yeah. But for ungauged basins where we have to make so many bridges, all that things. And at that time, there was a say mandatory things for the institute that if you do a dissertation, then you have because of this road construction, automobile and road construction institute, you have to address somehow the road or automobile like this. And these things we also considered in Fulto campus and Institute of Engineering also. So at that time, I was just confined my dissertation work to road structures only. Now you can understand that why only road structures. Okay, so the need The need of research was at that time damage of roads and road structures due to heavy monsoon floods, lack of government norm and the standard on frequency of flood for the passing structures. Because you see, always we use the IRC or some other norms used in foreign countries, yeah, outside of Nepal. But we don't have some norms and standards, good standards and norms, still lacking. Still, at present also lacking. Because when I meet some our officials in DOR, I always talk to them. So we have to work out these guidelines, the standards, all these things. So you see, at that time also, I still need that lack of government norm and standard on frequency of flood for the passing structures is required, and lack of long-term runoff data for the accurate estimation of flood at that time also, because the gauge basins are very few at that time, and even rainfall data was very few. So you can say that the maximum rainfall data was of maybe 30 years, not more than, and less than 20 years there were so many stations. So lack of regional methodology. This last one was my output of research. Lack of regional methodology and empirical relations for the prediction of flood in ongoing basin. So that's why we set this objective. Only two objectives. You see, now we have some PhD students in Pulsar campus and master degree students, and I am a member of DRC also, Departmental Research Committee. And when they are presenting, I just you see they have so many objectives, 4, 5, 6 objectives. No, that is not good. You have to take only one or two objectives or three objectives, so that you can do the job better. So still, you people are also doing their in US master degree or PhD, wherever you are, if you are say dissertation or doing thesis, then this is very much important that you have to show the research gap, and objectives should be confined. So to work out the regional method, that was my objective. So how to predict the flood, and then again we confined that the flood may be predicted by gauge data, yeah, flood data. But if the flood data is not available, then how to predict in on-gauge basin? That was the objective. So to work out the regional method, regional because for Nepal, for the prediction of design flood rainfall in on-gauge basin of Nepal, to recommend the frequency of design flood for different category of structures. So this was the second objective, because you see, nowadays the Department of Roads has say fixed that all the bridges in Nepal should be designed for 100 years return period. That is not good. That is not correct. That is why if even you say in village roads, when you are going to make a bridge for say for a length of 10 meters or 12 meters, and you are using 100 years return period of flood, that is not correct. Yeah, and even you are making a railway bridge, which is say 500, 600 meter of span, or the Kosi, even 1.5 kilometer span.
Yes.
Still, you are using 100 years plus.
100 years.
That is not okay. Okay.
Not yes.
So we have to fix the frequency of design flood for different categories of structures. That is the I think process of all countries. They have, okay, we can fix, but again we have already studied in hydrology that we can fix the risk, how much risk the client will take, and what will be the project life. And the formula, the best formula in the world, I think, the best formula will give you the frequency of the design flood. But That frequency, I think, will be very much higher than what we think, and that is why different countries have been fixed the design slot for different structures. Okay, so only two objectives. Then data which was used at that time in 1996 means I had been working in say from 1993, and that time you see the data could be used only for up to say 1990. Even 1990 was not published. 1985, 19, but 1990, however, up to 1990, I had used the data rainfall records from DSM, and that was not sufficient. That is why rainfall records collected by Soviet Road Project. At that time, there was no Russia, that is Union of Soviet Socialist Republic, USSR, that was called in 1993 at that time. And this Soviet Road Project was all over the world, in Africa, in Asia, and they collected the data. So my supervisor was at that time collecting the data along the Patlaya Dhalkebar road, and then they have made some. And when I was his PhD student, once he took me to his storeroom, and there was so many data collected in that time, 1967, when this road was constructed. So many data I have found from his storeroom. Okay, then this is very important methodology. So this methodology is still, I think, very much useful for other researchers who are, say, um, finding some results for crop prediction. Okay, so collection, quality analysis, and preparation of rainfall data. Okay, and obtained by the project and DSM. ಅಲ್ಲಿ यतातिरको देखिएन हैन यसले यसले चाहिँ चेक गर्नुहुन्छ मैले मैले यसलाई हाइड गरिदिए भने तपाईहरुलाई फरक पर्दैन हैन ठीक छ ल ओके अब पुरै देख्ने हो अब चाहिँ so दुईटा भयो हैन from DSM and from stage door process analysis and generalization of similar past research work analysis sorry analysis of theoretical base for the selection of design model of maximum for this part हैन that is everywhere. For every research, you have to find some theoretical base. Then numerical experiment, mathematical modeling, and determination of result parameters of plot, and comparative analysis of results with direct measurement. So, my supervisor at that time, when they were making the Patlaya Dhalkebar road, they have done some direct measurements, and we have used these measurements for validation. So this is the output, okay? This is the output after 3 years. I have dissertated in 1996. That is QP, means probability. There is a probability which we call return period. That is 16.67 AP OP 5 F KF plus QS. This QS means if the river is from snow melting, perennial like Karnali, Kosi, and Narayani, Brigantaki, and then you have to estimate this plot from snow melting. So this can be worked out, this formula for Nepal. Still, this has to be modified. But at that time, our main concern was storm flood. You see, rainfall storm flood that is below 5,000 meters. So from monsoon, that we can say monsoon flood. Okay. So QS is discharged by melting of snow, can be taken as 0 to 10%. That is just by experience of Russia at that time of QP in the absence of data. Okay. And you can see, I think I have sent all these things to you also. So you can go through it, and if there is any say misunderstanding or not understanding, then I think I can explain you later. But one thing is very important that was very much say difficult for me at that time also. Also. About 2 years, I was just working these things. You see, maximum rainfall design intensity for required exceedance probability in millimeter per meter. So the main thing you see, this formula is likely a type of rational method. In rational method also, we use the coefficient C, yeah, which is runoff coefficient, and there are so many parameters in runoff coefficient. Then we use the intensity. Intensity was used in rational for time of concentration, okay, time of concentration. And then catchment area. Catchment area is always used, I think, in this rainfall runoff model. So F is the catchment area here, and Kf is the coefficient of unequal distribution of rainfall in different kinds of basins. But this is important. So you see, maximum rainfall design intensity for required exceedance probability have to be used for defining the say flood by return period or by frequency. You see, you have already studied Dickens
Uh,
formula
Dr.
ability.
PCJ, sir,
Ah,
I'll interrupt you.
ah,
One of the participant has said that, like, can you make the screen full?
skin phone.
Yeah, can you make the screen like full? Can in the presentation mode? Can you do that?
Begin.
Rakesh,
Can
can
you,
you
sir,
please?
sir, can you zoom it? And I mean, that is just
Yeah, yeah,
increase
yeah. The left one, yeah.
presentation presentation mode in
No, presentation mode, yeah.
Presentation mode.
Yeah,
just
Correct.
the
So,
can you press the glass? Yeah, 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 that one, yeah.
because
yes, yes,
I
yes, yes.
Yeah,
understood
now,
because this has not been seen. Yeah, okay. Okay, so
yeah, yeah, okay,
you
yeah.
see,
Please continue.
yeah, this was a big problem for me, and I worked out about 2 years. Okay, because you see, at that time in 1993, the total rainfall station in Nepal were, I think, 256 stations. And with my supervisor, we selected only 142 stations, which has more than 20 years of data. Okay, so other stations have 9 years, 10 years data, and we just started it. So we worked out on 142 stations, and the 24-hour maximum rainfall. We say it's daily maximum rainfall also, about 24-hour maximum rainfall. So for all 142 stations, we have done this frequency analysis, okay? And then we got the 24-hour maximum, say, in return period, okay? And at that time, you see, there was no computer, and all things we have done manually in graph paper, all these things, okay, by selecting these things. So then the problem was how to say convert this 24-hour maximum rainfall to this hourly design rainfall intensity. So that was found because from Indian literatures they have say Rao K and other say researchers, they have find some relations between 24-hour maximum and hourly rainfall intensity. And then for this relation, we have to use the very short duration rainfall. You see, 5 minutes, 10 minutes, like this, and only Kathmandu airport, Simra airport, and other two, three, four stations had some of the data, and my supervisor has collected some data for short duration. And then we find some for 5 stations, we find some relations, and that gives that from 32% to 45%. Okay, from 32% to 45% of 24-hour maximum rainfall is the hourly intensity of that literature. Okay, so that is already published in Soham Nepal paper. How to define the maximum rainfall intensity, hourly rainfall intensity from maximum 24-hour rainfall, and we can see that paper also. And then other this, you see, there are so many parameters used: infiltration coefficient and aerial reduction factor, okay? And this reduction coefficient of hourly rainfall intensity, because hourly rainfall intensity is the main parameter of monsoon rain in Nepal and India that creates the peak, flood peak, okay? So that also depends upon the size of catchment area, this reduction coefficient. If the basin is very large, say, and then it will be giving lesser peak, okay? And when the catchment is very small, say, then the peak will be higher. So KT is also very important for that. Let me go now, say, briefly all these things, because these are all these things. So space time distribution of yearly maximum, monthly maximum, daily maximum, all these was worked out, and the best relation was found with daily maximum, 24-hour maximum, the hourly rainfall, okay? And then verification and establishment of revised average yearly total rainfall, ISO heights for whole Nepal. We have at that time worked out, because GSM, Department of Hydrology Meteorology, was just say working on this, but we had already given this thing. So prediction of hourly rainfall design intensity from daily rainfall. This was a result of my research at that time. IIHR means hourly rainfall is 0.38. This is the average for Nepal, okay? But if we want to accurately find out, then we have to go for each station, okay? Each station, this coefficient will be vary, okay? And for finding this coefficient, we have to say collect the data of short duration rainfall. So say 5 minutes, 10 minutes, 15 minutes, like that, and then only you have you can work out this coefficient 0.38. So, and then DM is daily maximum and divided by 60, because this short duration hourly intensity is generally in Russia used as millimeter per minute, and that time we have given this unit, okay? So this unit can be changed, that is not a big deal. Determination of aerial reduction factor phi of one-time rainfall on area. So when the rainfall is, say, in Nepal, we can see that the monsoon rainfall starts in, say, like 3 days, 4 days, and even 7 days. Okay, the time of rainfall. And sometimes it comes very high intensity, 1 hour, 2 hour, or not more than, okay? So that aerial reduction factor was also found out, and establishment of relationship between the length and area of the basin. This is also a good work at that time. This we can generally for time of concentration, we have to measure the length of the channel. The length of the channel can be found without measuring for Nepal. If we find this catchment area, and then we can use this relation. This is very say thumb rule for Nepal. Okay, and then recommendation of the design values of estimated probability of maximum rainfall discharge for the design of different road structures of Nepal. I have already said you that that was a mandatory instruction from university, that you have to do the research for road structure. So this was at that time the recommendation for Nepal. So if category of roads 1, 2, 3, 4 type of categories of roads, that is highway like east-west highway, main Rajmarga, and then feeder and urban roads, you can understand the second category, and then district roads and village roads. So at that time you see even for bridges and culverts, for highway, you have to go for 300 years return period. But you see, if you go for 300 return period, the cost will be very high. That is why the Department of Roads is taken only 100 years for highway also. Okay, but you see, the second category is also taken 100 years by DOR, okay? And this, the third category of roads, district roads, we can make for 50 years return period. But still, they are using 100 years because they have fixed the 100 years return period for all the bridges, okay? And then you see, when you make a village bridge, yeah, village road, then it can be say designed for 33 years return period, okay? And then this is for side drains will be erected, and let's say this 4 means 25 years return period, okay? So for side drains, we can go for minimum 25 years return period, but in highway, you have to go for 100 years return period, okay? So this you see the practical value, use, and future scope of the research. Say this has been the washout method may be used in the hydrological system design of bridges and other road structures by the organizations of Nepal involved in planning, design, construction. So of course, this was worked out for road structures because of constraints of university, but this method or prediction of flood by this method can be used for, say, hydropower. I have firstly, when I came back to Nepal, I have used this for hydropower project. I will see this later. So the hydropower project, irrigation project, or water supply project, every project you can use this. Then one of the limitation of this research was up to 300 years only. So up to 300 years we can predict the flood. But however, we can extend up to say 1,000 or 10,000 also. Of course, that will be not very accurate. Of course, that will be some because the higher return periods need say long-term say reliability and data. Now, present method gives the possibility to consider the formation of maximum rainfall discharge from both a small and large river basin. This is one of the, I think, very good thing of this research, this formula, that you see, most of the formula has a limitation, that it can be used only for a small basin or it can be used only for large basins. But this formula can be used for a small as well as large river basins, and the results are very good. For a small basin, the flood peaks are higher, and large river basins, the flood peaks are say moderate. Okay, as this method fully satisfies the scientific base and requirements of maximum flow for the road construction norm, the result methodology can be further recognized as a national norm. So we can, and I think Department of Roads has promised me that they will be executing a workshop, and there I have to present all these things, and they will make a standard norm for the estimation of flood, and maybe this will be also this say formula or method will be given for, because you see bridges, culverts, and other road structures, especially this was worked out. And then irrigation, water supply, other use there have been, I think, 142 stations, which I have mentioned, and 20 years of data, and then this was used. And determination of plots in Angaz, especially in Angaz river basin, and especially in the hilly and mountain areas of Nepal. Oh my God.
I think PCJ sir's screen is interrupted. Please have patience. Yeah, he has some technical problem, I think. Yeah. Hello.
Hello.
I think PCJ sir has got some technical problem. Yeah.
Mm.
Rakesh sir, like if anybody or Rakesh sir have
Okay, sir.
uh,
I will I will
have
contact
his
him. Okay.
personal contact, yeah, can you contact
Yes,
him
yes,
like
yes. I am
problem?
contacting
Okay.
him. Okay, sir.
Sorry for the interruptions. So I think PCJ sir is having some problems. Okay. In the meantime, like if the participants have any question regarding the methodology and the parameters in the equations, the design flow equations, like maybe you can write in the chat box. We'll select some of the questions and then we will present it to PCJ sir so that he could have a more explanation on it. That we'll do in third part of our session. Okay, please do
I
write your
think
question.
I think he's joining. I think he has some electrical problems.
Okay.
उहाँको के खुट्टाले लागेर होइन तारमा यसो के भन्छ अन अफ भएको छ के अनि फेक जोइन गरिदिनु हुन्छ उहाँ
Okay. Okay. That's okay.
अनि सर अर्को कुरा सर उहाँले जुन स्क्रिन सेयर गर्नुहुन्छ नि त्यो पुरै फुल स्क्रिन
हजुर
मोडमा चाहिँ सेयर गर्नु भन्नु ल सर
ए हुन्छ अहिले आउँदाखेरि बनाउँला त्यो कुनै कुनै पिसीमा त्यस्तो हुन्छ तपाईँको
ए
मेरो पनि अफिसको ल्यापटपमा त्यस्तै हुन्छ यो एउटा योभन्दा अगाडि
Okay, okay, okay.
सर
Sorry,
योभन्दा
sorry
अ,
for the interruption. यहाँ एउटा के गरौँ
योभन्दा अगाडिको स्लाइडमा सर हामी थियौँ सर
ठिक छ मेरो यो कस्तो भयो भने
हजुर
मेरो स्क्रिन फुल स्क्रिन आएन के मेरोमा फुल स्क्रिन आउनु पर्ने होइन अच्छा ठिकै छ मेरोमा नआए भने तपाईँहरूकोमा आइराखेको छ फुल
हजुर हजुर अहिलेको सर सही छ ठिक छ सर
अहिलेको ठिकै छ सर हजुर
ल ओके त्यसो भए म गएँ है त ओके
हस्
सो
सर
देन Hilly. Okay, last one. The method gives third value in higher side. Okay, so this is the experience from say my experience in Nepal after coming back and using this method for flood prediction in different sectors, say irrigation, hydropower, basically in say road structure. This third value is in higher side. So in Nepal, we use this West DSM 1919. That was also developed by Water Energy Commission Secretariat and Department of Hydrology Meteorology in 1990. Okay. So at that time, and my say this method was developed in 1996. So these are say contemporary methods, and at that time they have used this gauge data for the regression equation and the West DSM, and then DSM 2004 was worked out, and modified decans was worked out by Roorkee University, now IIT, and then say other US methods also, like BD Richard was used at that time also, and then Snyder. This time we use this Snyder, say hydrograph method also, and other methods. So in Indian continent there are some empirical methods. So this method technology was compared basically by me and by so many students. The comparison was made by available methods, and this method was even giving higher side results. even compared to SDSN and other methods like Dickens method also, because Dickens at that time, this method was not giving the say flood for some return period. That was only very old time when the bridges were constructed by Dickens. So many bridges were constructed by Dickens method in Indian continent, and that was simple Q maximum. Okay, Q maximum CA to the power n, and C was worked out for North India, and n was also worked out for North India, and we were just using this Dickens method for making bridges. I think 100 years ago, maybe at that time. Okay, so this is very interesting that we are searching the methodology which can be used in on-gauge directions of Nepal, but I'm very sorry to say that say in Nepal, the collection of data, which is the responsibility of Department of Hydrology Meteorology, that is also still not so good, okay, because the data is not consistent, and that is why the researchers have to be say very careful in predicting this flood. Now, implementation of research methods, this is in 1996 at that time in the study of different projects in Nepal. So I have earlier said that one of hydropower projects when I came in 1996, this you can see SAC Consult International, that is hydropower consultant. In 1997, Indravati 3 hydroelectric projects in Nepal having a feasibility study, and this methodology was first used in this project. Okay, then Karra Khola Bridge, Makbanpur, Satwal, maybe at that time I think say about we have used this method about more than 25, 26 years. Maybe more than 500 bridges in Nepal I have already worked out, and other say my students or other colleagues have been worked out by this method. So this is I think not appropriately to say that if this method is giving in higher side result, that is safe side, that is we hydrologists say it's safe side, but it again not be economical. So generally I even instruct my students also and my colleagues also that let us use all the formulas, let us use all the methods available in continent, okay, and then let us compare. And when you compare, then if you have some experience, then you can select the method. Which method can be giving you in safe side also and cost effective also. But always in classes also I say that first you prefer the safe side, okay? Firstly, safe, okay, safety, and then only economy. But you see, in developing countries, generally, the government people they use firstly see the cost, okay, so be economical, and then only they think about the safety. That is wrong. We always first we have to take the safety purpose, and that is why I'm saying that in all these say structures, which I have listed some few only. We have recommended the flood predicted by PCJ 1996 model. Okay, so these are, you see, Arua Khola and Hadia Khola, Ratua Khola, Sarda Khola, small hydropower project, Arun Khola hydropower project, all Karachi feasibility study. So there have been so many. Just for comparison purposes, I have put some of the values. Let's say the first hydel project in which I had used this methodology, West DHM had estimated 783 meters cube per second for 100-year return period, and then PCJ has estimated about 865 meters cube per second. Okay, and you see basin area. This is important because 437 square kilometers. This is catchment area. Okay, so nearly two two times, as we see that in medium type of basin means up to 1,000 square kilometer, the 100-year flood in Nepal is about 2-3 times, okay, 2-3-4 times like that. And when we go above 1,000 square kilometer, it will be reducing up to maybe 1 times also. Let's say if 20,000 square kilometer, then 20,000 meters cube per second, not more than 1 time only. But when you go to small basins, let's say 1 square kilometer, for 1 square kilometer, it will give you 10 times or 12 times or 15 times of catchment area. That is my experience. That is my experience of 25 years, 26 years, I say, prediction of flood. And then you see Karra Bridge, 383 square kilometer, but 947. The method gives 947, say more than Indravati Hydel, which has only 437 square kilometer. How this is possible? When you use only catchment area, then of course it will be reduced. Yeah, you can see it in, say, West DSM method, okay? But the PCJ uses the hourly intensity of rainfall, that is called the design rainfall, and that differs from location to location. So this Karra Bridge is located in Hetauda, and at that Hetauda state, the rainfall stations have received so many, 24-hour maximum rainfall very high. And that is why this PCJ is giving 947. Now, if he constructs the bridge for 380 meters cube per second, of course that will be not in safe side. But again, you can say, okay, then 947 is in safe side, but the economy, yeah, if you are not capable to pay or say expense the bridge cost, then you don't make the bridge. Better you don't make the bridge, but if you make the bridge or any structure, any hydraulic structure, then you have to go for safety purposes. First is the safety of the people, okay? Then you see Satwal Khajuria Bridge. Again, this is in higher side of West DHN, you can see. But when we come to a small catchment, like 13 square kilometer, you see, then it seems that 104 West DHN meters per second, and this 150. So approximately 10 times the flood is, you can just say that thumb rule of catchment area, okay? Now Chandi Bridge, you see, the same and giving the same result. Sarda hydropower, 379 square kilometer only, but is giving 941. So West DHME, more or less, they have found some gross data at that time, and the regression analysis has created an empirical relation. But PCJ is not empirical because it uses the rainfall, even intensity of rainfall, hourly intensity. That's why it will give the correct value. Now, what I have said you that about 2 years I have expended in this methodology, and that result was for 142 stations. We can find it in research data also, the maximum rainfall intensity of Nepal. So 142 stations, these are the stations, 101 starting from west side of Mahakali, 103, 104, 106. Now this is Mahakali, and 2 is Seti, and like that 14 will be Mechi. So 14 general codes are there, and 1, 2, 3, 4, 5, 6, like that is the station number. So 300 years, 1.08, it is in millimeter per minute. So this is hourly intensity, and that will be multiplied by reduction coefficient, KT. Reduction coefficient is dependent on the catchment area. Okay, so if large basin, the coefficient will be lesser. So for 100 years, 50 years, 33 years, and 10 years. Okay, so these 5 years, return period years was worked out at that time, considering the construction of road structure, side drains and culverts and bridges, all that. We have already seen that how we have categorized the roads and recommended the frequency of flood. Okay, so this for 142 stations, this frequency analysis by different distributions, and most of the stations were, I think, fitted on gamma. Three parameters gamma distribution. That was the best fit for most of the stations. So this result is already in Soham Nepal paper, and say research that also have to it. Okay, and one of the results at that time we have given this hourly intensity of 100-year return period. 100-year return period, hourly intensity. I have plotted all these 142 points, 142 stations. This small points are shown here. And these ISO lines were developed for Nepal. And we can say if our catchment is located somewhere, then we can find these stations also and the values. Or we can take from this ISO lines graph also approximately the hourly intensity, because that is the most important parameter of PCJ 1996. Without this parameter, we cannot even use this method. That is why this is important. Okay, so now I want to show you now see modified, which you have already said at that time. Okay. स्टेप गरेर जानु पर्यो एकैछिन है त So I think yeah, okay. So we can go for modified. That is not a big deal, and that will be, I think, not very long time. I think let us go for some discussions or views on this 1996 if there are some unclear things, and then just I will go for this modified. Okay. Modified 2024.
Yeah, that's also sounds very good, Professor PCJ sir. One of the participant has asked you a question, so I'll try to iterate that question. He is Niyaz. One of the participant has asked a question regarding your 1996 method.
Okay.
So his question is: if we find hourly rainfall using maximum daily rainfall, how will be the distribution of rainfall for every hour? How will be the distribution of rainfall for every hour? Using this formula, we may get a constant hourly rainfall for a single day, but in real, the intensity of rainfall varies a lot throughout the day. How to solve this?
Yes. That's very nice. It's a good question. And you see, in general, we can say that if you don't have data, if you have the certain, earlier I have mentioned that if we have short-term, say 5 minutes, 10 minutes, 15 minutes, like that, if you have recording gauge station, then you can get the data, and then from frequency analysis you can use the hourly intensity, varying intensity, all that. That is the solution. That is the best solution. But at that time, even in Nepal, there was no recording gauges. Okay, only this non-recording Simon's type manual gauge, and which gives you the 24-hour accumulated total rainfall. The distribution of rainfall we cannot find from non-recording gauges. Okay, sir. So,
okay.
But we had to solve the problem of flood prediction for the structure, because you cannot stop the making of a structure. Okay, and let us take the data, and then after 100 years we'll make the structure. So The structures you have to, even at that time, we have to design from Dickens' method, which is not giving you the even return period, only maximum plus. So we thought all these things, but in absence of data, we just found from Indian literature also that in average, because the main say principle of this research was after finding the literature. So the maximum hourly intensity that we call after multiplying this reduction coefficient, the design hourly intensity is responsible for creating the flood peak. Okay, this is the hypothesis. So this design intensity is the maximum intensity during the duration of the rainfall. That may be 5 hours of rainfall, that may be 1 day of rainfall, that may be 3 days of rainfall. But the hourly intensity will be maximum for that period. Okay, I think if there is any other queries, I will address on that. Okay.
Okay, sir. There's one more question, like from Pitambar Wagle. He said that in the same context, my query is why isn't DHM recording data in hourly format? Most of the times we are working with daily data only.
Pitambar is my say one of the best student. I remember him always. He wears topi. We call them. So you see, Pitambar, you are also, I think, familiar with our the economic condition of country and our leaders and all these things. So you see, this time, none of the ethnic country is using this time and time. All are using recording projects. You see, because in our context, even people are not interested in collecting the data or honestly collecting the data. So we must use the very, I think, not very say costly tipping bucket type. Okay, so tipping bucket type is the best recording gadget. It can give you the every minute fluctuation in rainfall. But unfortunately, we have to realize that at this time when I was modifying my methodology, which is in 1996, the total station in Nepal is about 400, more than 400. At that time, when in 1996, it was 256, and I selected only 172. At this time, more than 400 stations are there in Nepal, and the recording gauges are used maybe only for 30 or 40 stations. These are the airport stations. Because of airport, we are using rain gauges recording. Otherwise, more than 300 stations are still Simon Stack, non-recording. And that is, say, due to cost, or maybe our government officials or our government is not understanding the importance of data.
Okay.
I think I have clarified. Okay.
Yeah, I have personally one question, like before you go to your modified form of 1996 PCJ model.
Uh-huh.
So like how your model compared with the like distributed model like HMS and SWAT? Have you like compared the
Uh-huh.
design discharges from these
Mhm.
models with your 1996 PCJ method?
Okay, so good question. You see, actually, I didn't find sufficient time for developing again the modified form of PCJ, because you see, at that time, when I came back to Nepal in 1996, and I was very eager to use this methodology because this was my PhD dissertation, and at that time in Institute of Engineering, I think not more than 4-5 PhDs. Okay. So I was very much say enthusiastic at the time, and when I was out with my students, and then I take their location and catchment area, and then I came back to home, and then this was written in Russian language, all these things, my dissertation, and finding all the parameters, and then it took, I think, 3 hours, 4 hours, even a day to define me the 100-year flood or 50-year flood. Okay. And then after say 5-6 years, or one of my students, two students actually, one girl and one boy, in 4th year, and I just requested them, and at that time the Excel was developed. Okay, the Excel sheet was developed. They have developed. My students, they have developed, because I was unable to know all these things of Excel, and they just take all these tables and values, all these, and by programming it in say Excel, and then it became very easy. Okay, so the thing is, even at this time, I found some very critical moments to because of my book, because I was just publishing my book, and then I have to give some my methodologies in this book, and that is why this method was worked. Actually, HSMS have worked out one or two, I think, projects, and this is you see the model part, or HSMS, or other model semi-distributed, what you say. These are also you have to calibrate some parameters and then validate some parameters. And again, the problem is calibration and validation. You see, the most of the models are facing the problem of, even some of my students are doing masters and PhD. They have already said that the problem is calibration and validation. Okay, in my method also the problem is validation. Okay, so calibration and validation. So validation, how you validate? Because for validation you need the flood data, gauge data. And when you are using for uncaused basins, like say by rainfall, then either you have to measure the flood at that time, minimum 1 year, 2 year, 3 year, 4 year. Yeah, the collecting of data is very much expensive. You see, very much expensive. That is why Department of Hydrology and Meteorology is not taking all these things. But again, I think there will be some time after my retirement, and I will be going for these semi-distributed models also, and validating or comparing, not say validating. I will say that maybe comparing with HHMS results and other SAT results or other results. Okay, but
Okay.
at this
Yeah,
time, I have not compared with this models. Okay.
it's just a thought, Professor PCJ sir. So please go forward with your modified form, please. Yeah, thank you.
Okay.
Okay.
So there is a LRBP, Local Road Bridge Program. This is, I think, financed by and supported by UK. UK के भन्छ त्यसलाई, UK को के रहेछ, UK को एउटा छ नि त्यो किसहरूको क्रिकेट जस्तै हैन, UK को एउटा रहेछ, अहिले याद आएन. Okay, no problem. So this UK funded program LRBP, local roads, generally these district and village roads. Okay, they have, I think, a long time ago, maybe 15-16 years ago, they have asked me for the regional analysis of floods, okay, or hydrology. So hydrological zoning of Nepal. And at that time, I have prepared some papers, okay, for what is the possibility of hydrological zoning, how we can say distinguish the zones, and then I have presented this paper. But however, I think this was a stop. Okay, this was a stop, not gone. Okay, but in my mind, there was still say, when I will be free or sometime there will be. I think I will be producing hydrological zones because later we introduced this MIP method, as you also use this MIP medium irrigation project, and they have zones, hydrological zoning in 7 regions. Okay, MIP regions. Okay, 7 regions. And that is, I think, according to based on the long-term discharge, okay, monthly discharge, similar rate of discharge per square kilometer unit specific plot, sorry, specific discharge, okay. But in Nepal, the varying topography, and varying monsoon from east to west, you see. This is the very much, I think, critical for our flood prediction. North to south also we are varying, and east to west also we are varying. So I thought that at this time, so for preliminary, maybe next time after 2-3 years we'll be refining this hydrological zone also. But first time I was just thinking that okay, so even if I am working on rainfall stations, then at this time about 300, you see, 1996, 142 stations. Now I have 300 stations which have more than 20 years of data. So I worked out all these stations, the data analysis, and the data was also added because at that time only up to 1990 data, and now 20 years of data and more than 20 years of data has been added to the stations. Okay, and I used this PCJ 1996 for defining 100 year, only 100 year now. Okay, defining because 100 year is used in most of the say structures. That is why 100 year is very popular. So 100-year flood by PCJ 1996 using the recent added data and recent new stations also. For 300 stations, up to say 2000 up to 2020 data, and using PCJ 1996. Again, I am saying that the 1996 is used for this. Okay, but considering climate change effect, so some increasing more, and debris also, sediment debris should be also considered, in my opinion, and I am considering in the project. Okay, so again, this has been increased, and I have worked out this say because you see there are so many parameters, and then I thought that okay, I have to find some simple relation like Q is equal to CA to the power n, like modified decay. Okay, and if I define the C value and n value for all the stations, then you don't have to go in 1996. You just find your stations in your catchment or around your catchment, do the thicken polygon, and use the C value of each station, and you can find the 100-year flood. Okay, so I am.
Sir,
Are you sharing your slide also, or
Yes,
is it just
yes.
a background?
No. I'm sharing you now slide. Okay.
Okay, I also thought like that. You are sharing your background, then you'll share
No,
your
no, no,
slide.
no, 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 no. This
Yeah.
was only talk about the philosophy. Okay.
Okay.
Now I'm. It is not. I think created on slide. It's Excel sheet. But
Okay.
I think. We can not in glass.
I think you can share your Excel sheets screen.
Yeah, you can share.
है ना.
It's
मगर अहिले share त भइरहेको छैन नि.
छैन सर.
पहिला चाहिँ त्यो यसलाई म सेयर स्क्रिनमा जानु पर्ने हुन्छ के है ना? Okay, now it's in okay. देखिरहेको छ नि अहिले
छ सर
तिमीहरूको यसलाई चाहिँ म बरु हटाइ okay. So you see now this one, right. So let's say this one station 1403 1403 1403 this is from Mechi zone, and still I don't remember this station name. Maybe this is the one of the T state, okay, T state, okay. Here I think yeah. Just 1 minute, huh? So 14.3 is Lungtung. You can see this. I think I have to zoom in and then okay. Yeah, now it is clear. So
Yeah, it's clear,
you see,
sir.
so it is 100-year flood only, okay. So because it takes too much time. It takes too much time to work out for all the return period, and I think after some time I will work out for 50 years return period also, because 50 years is also very much used. But now for first time 100-year flood, that is by PCJ 1996. Again, you see here the formula 16.67 hourly intensity and KTOP, phi, KF, yeah. All here this phi parameter and all these parameters, okay? But for you see, the one station is Lungtung, which has observed maximum daily rainfall, okay? Observed maximum daily rainfall, say for up to this time, the data is 291 millimeters, okay? So one day maximum rainfall for maybe 30 years of data, it is 291 millimeters in 24 hours, okay? And when it is done in frequency analysis, okay, it gives about 286 for 100-year return period, okay? So this means that the 30 years data is giving 291 millimeter, 24 hours rainfall, and when it goes to the frequency analysis using this speed distribution, it is giving 286. That means already 100-year return period rainfall has been occurred at this station. Okay. Now, from our let's say at this time the 0.38 times the daily maximum which I have used at that time, because this is also one of the big research, will be big research that each station has to be defined for their coefficient, okay, individual coefficient. And maybe if you people are interested, you can do all these things. But again, we need the data. Without recording rain gas data, we cannot find the say converting daily maximum rainfall to hourly intensity. But here you can see that just simply I have used the average value of Nepal from my research, 0.38 times this daily maximum. Okay, so 1.81 millimeter per minute will be the design intensity. Not design intensity. Design intensity will be after multiplying this coefficient KT. So this will be hourly rainfall maximum hourly rainfall intensity of this. Okay. Now I have to go here. Okay. So you see, this is the area for kilometer square, 0.0001 square kilometer. So very small catchment. Okay. And 1,000 square kilometer. I have to go because you see more than 1,000 square kilometer. There are very few catchments, big catchments, and they have gross data. So we can find flood from say instantaneous flood maximum data. But again, another basins are located beyond the 1,000 square kilometer. That is why I have taken 0.001, 0.001, 0.01, 0.1, 0.5, and 1 square kilometer. Okay. Here is the 1 square kilometer, which we always say that this is a specific flood. Okay. So meter cube per second per square kilometer. That means for 1 square kilometer. Okay. And then 10, 50, 100, 1000. This is our distribution of catchment area. Now I have used the PCJ 1996 with improved rainfall data. Okay, improved. So added rainfall data and considering the climate change also, increasing the rainfall for climate change also. Okay, so it gives me this value. Okay, you see, for 1 square kilometer, it will be about 18 times of catchment area, 18 times. But when you go for 1000 square kilometer, it will be about 2.5 times only. Okay, so this is the plot for various catchment areas, but only for 100 years research period. Okay, the frequency is fixed for 100 years. The catchment area has been varied. Okay, now you see the 1403 I have plotted here. Okay, so 1403, that value for catchment area. Okay, I am just zooming it for you. You see, now it is clear. Okay, okay. Isha?
Yes, yes, sir. It is clear.
Yeah, it's
Okay.
clear. Yeah.
So you see, the smallest catchment area of 0.0001 square kilometer. Okay, and here is 1000. Okay, distribution. Then Q is here. This one 17.97. If you remember on that sheet, and 2511.96 meters per second for 1000. This is for Lungtung station, especially for 1403 roll number Lungtung station of Mechi. Okay, and then this area versus Q was plotted. Okay, this area versus Q was plotted, and this blue dot is the PCJ prediction, PCJ 1996. Okay, and now I have fitted this equation. Okay, exponential equation. Just say Q is equal to CAN. CAN, where S is here catchment area, and this is our N value. You see, for North India, Dickens about 100 years ago, considering only few catchments, he has found the N value for North India as 3/4, means 0.75. But my research, this modified research, has given or found that for all over the Nepal, the distribution coefficient is similar, 0.776, as I can show you. And this R square is also good, 0.9179. And this is the most important value we wanted. That is at Lungtung station. If your catchment is, or your this station is within your catchment, let's say small catchment, only 1 station Lungtung is in your catchment. Now you can use just for 100-year return period. This P value and N value is already fixed, 0.776 for all stations of, because it gives like that. Some minor changes will be there. There must be some minor changes, but mostly this gives the aerial distribution of Nepal, which is uniform for Nepal. Okay, but this P is the all parameters which PCJ 1996 used. There are 8 or 9 parameters. This is the combined effect of say runoff coefficient. Okay, and the Dickens was recommended. Dickens has been recommended for North India. This value from 10 to 15. Okay, 10 to 15, depending upon the location. In this research, modified PCJ 2024, also we have find that this value has been changed for all the stations. Okay, so Now I have just used this equation Q. Okay. Now this value is from equation. This is from equation, and Q by A ratio. Q by A ratio is also plotted. You see, this is for Lungtung Q by A ratio. This is the mistake. This is Q by A ratio. Q by A ratio. What does it mean? Q by A ratio. You see, PCJ Q by A here is 18. 17.97 is Q meters per second for 1 square kilometer. That means 18 times at Lungtung station, 18 times the runoff will take place. Okay, and when this red equation, according to equation you use, then Q by A will be 15.6. That is reduced because the PCJ 1996 is not in a straight line. Okay, but we want to produce simple methodology, empirical, but it is not empirical because we are using the rainfall. Okay, so this will be reduced. But when it is goes, you see, for let's say 0.0001, very small catchment, this is a Q by A will be 92.9 times. When this value will be used, it will go for in higher side, that means in safe side. Okay, always we say that it will be in safe side, but will be costly structure. Okay, and again for 1,000 years, when the catchment is very large, you see, this is a Q by A is 2.5, that is more economical, but not in safe side. But when we use this equation, the regional, say, hydrological zoning equation, then it will give you 3.3. Okay, so Q by A ratio is decreasing. Q by A ratio is decreasing depending upon the catchment area. Okay, so when the catchment is small, the Q by A ratio is more, and when the catchment is large, the Q by A ratio is decreasing. Okay, now you see, this all district equations has been worked out. You see, this all 400 stations, you see, the C has been worked out. And you can see the variation of C. Even 5.80, Kaledi station, Solukhumbu, only 5.80 C. You see, and the highest value of C we have obtained is EC, Kanyam T estate, Ilam, 20.4, 22.15 in Dhamma, Chandragari, because the monsoon starts from at that point, you see. So that is very much interesting result. And here, when we go for west, like say Kailali district, Godavari West station, only 16.60. Let's say Assam, 7.52. So all stations I have worked out about 3 months. I have spent fully, say very accurately, because it has been worked out. All the graphs have to be plotted for all the stations. Okay. Now, this is, you see, the conclusive value of eastern region. So how I have started the zoning concept, I have to show you here the zoning concept. Okay, so this is one of the map of Nepal. Is that clear, this map?
No, sir, we cannot see that map yet.
So I have to then share it, yeah?
Okay.
Yes.
Again, I have to then share it, yeah? Oh my
Yeah,
God.
you can cancel this Excel sheet, then minimize this Excel sheet, then
that I have done this. Okay, no problem. Let's see first this one, and then I will close, and then I will show you that.
okay.
So the concept is okay. So the concept is Starting from the rainfall station, that is about 300 stations, 297, that means about 300, okay? That is a good thing, I think. 300 stations in Nepal has been worked out. Then coming to the hydrological zoning, okay? So we have districts. We have districts. Are they in participants? We have some U.S. nationals or foreigners. Yeah. Only we are Nepali. Yeah.
Yes, yes,
Yeah,
yes.
most of our Nepali, sir. Yeah.
Okay. No, some of our foreigners nationals or not.
I don't think so. Let me check.
ओके ओके त्यसोभए ठिक छ त्यसो भए अलिकति चाहिँ के छ भने म नेपालीमै जान्छु अलिक
Yes, yes.
फास्ट
ए
हुन्छ
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 सर, हुन्छ हुन्छ, केही
हस्
छैन।
हस्
त्यसले मलाई त ईश्वरले सुरुमा अब त्यो इङ्ग्लिस भन्यो अनि त्यसले गर्दाखेरि मेरो त्यो खासै त्यस्तो बानी छैन क्या इङ्ग्लिसमा गर्ने है त
हुन्छ सर, हुन्छ,
ल
केही छैन।
हस् सर
अनि 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 जस्तो कि 300 स्टेसनको पहिला चाहिँ वर्कआउट गरियो है त जस्तो कि तपाईँले म अहिले एउटा देखाउँ हेर्नुहोस् है अहिले अलिकति जुम जोसमा आयो
आयो सर
आयो सर, आयो।
100-year flood equations for all stations in all districts अरे के अहिले त्यो यिनीहरूले भागभण्डा गरेर 77 बनाएको छ नि जिल्ला त तर
हजुर
तर मेरोमा 77 छैन के पहिलाको जुन 75 डिस्ट्रिक्ट हो त्यही
त्यही
75 डिस्ट्रिक्टलाई मैले मानेर अब
हजुर
इस्टर्न रिजन जस्तो कि हाम्रो कतिवटा रिजन थियो त्यतिखेर याद गर्नु त 5वटा होइन पाँच विकास क्षेत्र भनेको थियो नि त पूर्वाञ्चल मध्यमाञ्चल पश्चिमाञ्चल मध्यपश्चिमाञ्चल र सुदूर पश्चिमाञ्चल होइन हो अनि इस्टर्न रिजनमा कुन कुन अञ्चल थियो मेची कोशी सगरमाथा त्यसमा कुन जिल्ला थियो भनेर हामीले हेर्छौँ र एउटा त अब 5 विकास क्षेत्र भयो अर्को उत्तर दक्षिण दक्षिण जुन मैले भेरिएसनको कुरा गरेँ फ्रम नर्थ टु साउथ होइन त्यो त्यसलाई पनि 3 भागमा डिभाइड गर्ने के हामीले हिल इरिगेसनमा पढ्दाखेरि त्यसलाई 5 भागमा डिभाइड गरेका थियौँ होइन क्लासिफिकेसन त्यो टोपोग्राफी अनुसारले तर अहिले हाइड्रोलोजिकल जोनिङ गर्दाखेरि जम्मा 3टामा मात्रै डिभाइड गर्ने के एउटा हामीले के भन्ने भने माउन्टेन होइन किनभने अब हिमालयलाई लिएर काम छैन हाम्रो त्यहाँ त अब हाइड्रोलोजी गरेर काम छैन होइन त्यस कारणले के हुने भयो भने इस्टर्न रिजनमा अब 3वटा हुने भयो के उत्तरदेखि दक्षिण सबभन्दा उत्तरमा इस्टर्न माउन्टेन्स हुने भयो होइन त्यसपछि के हुने भयो भने इस्टर्न हिल्स हुने भयो तल शिवालिकसम्म होइन अनि इस्टर्न प्लेन्स हुने भयो ठिक छ भनेपछि कतिवटा रिजन भयो त अब 5 या 15 भएन हो 5वटा विकास क्षेत्र अनि 3वटा उत्तरबाट दक्षिण माउन्टेन हिल र प्लेन त्यो गरेपछि 15वटा मैले चाहिँ हाइड्रोलोजिकल जोनिङ चाहिँ अहिले बनाएँ ठिक छ कुरो अनि जसलाई त्यो मानौ एउटा जस्तो कि तपाईँको क्याचमेन्ट अलिक ठुलै क्याचमेन्ट मानौ इस्टर्न माउन्टेनमा पर्यो कसरी थाहा पाउने तपाईँ इस्टर्न माउन्टेनमा हो भनेर भन्दाखेरि तपाईँको जिल्लाहरू इस्टर्न माउन्टेनको हेर्नुहोस् ताप्लेजुङ सखुवा सभा र सोलुखुम्बु यो 3टा जिल्ला मिलेर इस्टर्न माउन्टेन बनायो भनेपछि तपाईँको अब स्टेसनहरू कुन लिनु पर्यो डिमुहा लुङथुङ ताप्लेटोक ताप्लेजुङ दोभान ठिक छ यो ताप्लेजुङको स्टेसनहरू हो सखुवा सभाको स्टेसनहरू सोलुखुम्बुको स्टेसनहरू अनि यो सबैको यहाँ इक्वेसन दिएको छ अहिले मोडिफाइड पिसिजे 2024 भनेको यही हो अब तपाईँको मानौ स्टेसन वाइज नजाने ताप्लेजुङ जिल्लामा तपाईँको सानो क्याचमेन्ट एउटा भन्नुहुन्छ नि ताप्लेजुङमा एउटा पुल बनाउनु पर्यो तपाईँ छोडिदिनु न स्टेसनको खोजी प्रेसिडेन्ट पोलिगोन आदि केही गर्नु परेन के ताप्लेजुङको डिस्ट्रिक्टको भ्यालु लिएर जानु नपत्या अहिले तपाईँहरूसँग त्यहाँ छ भने क्यालकुलेसन गर्नुहोस् अहिले 11.92 भनेको 12 हो यदि तपाईँको क्याचमेन्ट एरिया 1 स्क्वायर किलोमिटर छ भने 12 मिटर क्युब पर सेकेन्ड तपाईँको त्यहाँको खोलाले डिस्चार्ज चाहिँ दिन्छ 100 इयर फ्लड क्लियर भयो कुरो त्यस्तै तपाईँको मानौँ अब सखुवा सभामा तपाईँको क्याचमेन्ट छ भने हेर्नुहोस् बढेर आयो सखुवा सभाको, तर अझै तपाईँले एकुरेटली गर्न खोज्दै हुनुहुन्छ भने तपाईँले पहिला क्याचमेन्ट प्लट गर्नु पर्यो, त्यहाँ रेनफल स्टेसन्सहरू लोकेट गर्नु पर्यो, सिसन पोलिगोन बनाउनु पर्यो अथवा आइसोहाइटल मेथडबाट गर्नु पर्यो, अनि तपाईँले प्रत्येक स्टेसनको डाटालाई युज गर्नु पर्यो। किन भन्नुहोस् न, जस्तो कि हेर्नु त नुम भनेको एकदमै त्यो माथिल्लो जिल्ला हो, नुम कोही नुमतिर गएको छ होला साथीहरू, त्यहाँ हेर्नु त कति छ सीको भ्याल्यु 25, कति पानी पर्छ त्यहाँ भन्ने कुरो छ। अब रेनफल डाटा नै गल्ती छ डिएचएमको भन्ने त मेरो केही बनाइरहेन, किन डाटा कलेक्सन त मैले गरे होइन, तर डिएचएमको डाटालाई यदि ठिक मान्ने हो त्यहाँ अब कन्सिस्टेन्सीको कुरा अलिअलि मतलब हेर्नुपर्ने हो, मैले त्यति हेरेको छैन, त्यो अब धेरै टाइम लाग्ने हुन्छ होइन। तर ओभरअलमा हेर्दाखेरि नुममा हेर्नु त 25 छ, तर त्यहीँनिर तल आएपछि चैनपुर इस्टमा जम्मा 8.32 मात्रै छ त, कति भेरिएसन छ हाम्रो रेनफलमा है। त्यस्तै तुमलिङ टाढ भन्ने एयरपोर्ट छ त्यहाँ, उसको किनारमा के भन्छ अरुण खोलाको किनारमा है, त्यहाँनिर हेर्नु त 7.5 मात्रै छ भनेपछि तपाईँ अब नुमको नजिकमा हुनुहुन्छ जहाँ त्यो अरुण 3 बन्दैछ, अरुण 3 हाइड्रो पावर प्रोजेक्ट सुने होला होइन, त्यो पावर प्रोजेक्ट बनेको ठाउँमा उसको त्यति हाई रेनफल छ, अर्थात् त्यहाँको क्याचमेन्टले प्रोड्युस गर्ने हाई रनअप हो भने त्यही तल तपाईँ तुमलिङ चारतिर आउनुभयो भने पानी नै कम परेको छ है। त्यस्तै अब यो सबै 75 जिल्लाको मिलाएर जुन अहिलेको 300 स्टेसन भनेको कसरी छाँटियो, 20 वर्षभन्दा माथिको डाटा है, फेरि एकचोटि भने, किनभने 20 वर्षभन्दा कमको डाटा लिएपछि त्यति रिलायबिलिटी हुँदैन, तर स्टेसनहरू हामी थपिँदै जान्छ। अब हेर्नुहोस् तपाईँको यो डिस्ट्रिक्ट वाइड भयो, यो जोन वाइड तपाईँलाई मैले भनिहालेँ, भनेपछि कतिवटा हुने भयो त्यो हेरौँ है। इस्टर्न माउन्टेन जिल्ला आयो यहाँ, त्यसपछि तपाईँको इस्टर्न हिल्समा के आयो, खोटाङ आयो, ओखलढुङ्गा आयो, भोजपुर, तेह्रथुम, पाँचथर, उदयपुर, धनकुटा पनि आयो, हेर्नुहोस् इलाम पनि आयो इस्टर्न हिल्समा। अनि इस्टर्न प्लेनमा के आयो, झापा, मोरङ, सुनसरी, सप्तरी, सिराहा इस्टर्न प्लेन्समा आयो। अनि सेन्ट्रल रिजनमा जस्तो कि 3वटा अञ्चल छ, जनकपुर, नारायणी, बागमती भनेपछि पहिलो तपाईँको सेन्ट्रल माउन्टेन्समा रसुवा, सिन्धुपाल्चोक, दोलखा भनेको अर्थ के भने तपाईँ अब जोनिङ अनुसारले 15वटा जुन जोन मैले बनाएँ त्यो अनुसारले पनि निकाल्न सक्नुभयो, डिस्ट्रिक्ट वाइज पनि निकाल्न सक्नुभयो, स्टेसन वाइज पनि निकाल्न सक्नुभयो, र पिसिजे 1996 गइराख्नु परेन, किनभने त्यो अलिकति त अब कम्प्लिकेटेड नै छ, टिडिएस नै छ होइन, त्यसमा पहिला त अब स्टेसनहरू खोज्नु पर्ने हुन्छ होइन, तर त्योसँग कम्पेयर गर्न सकियो। यो मेथडबाट निकालेको सेफ साइडमा जान्छ भन्ने कुरा हो, किनभने क्लाइमेट चेन्जलाई पनि अलिकति कन्सिडर गर्ने भनिरहेछ मैले सबैले, इभन सेडिमेन्ट डेब्रिजलाई पनि कन्सिडर गर्नुपर्ने हुन्छ होइन। त्यो अनुसारले यो 1996 आफैमा सेफ साइड थियो, त्योभन्दा पनि अझै यो अब सेफ साइडमा गइरहेको छ है त। सो यसरी सबै डिस्ट्रिक्टहरू यो काभ्रे पलाञ्चोकवाला केमा आयो, सेन्ट्रल माउन्टेन र काठमाडौँ हेर्नुहोस् है, नुवाकोट, काठमाडौँ यो किन आयो, यहाँनिर के मिस्टेक भयो, नुवाकोट एउटा जिल्ला उल्लेख्न छुट्याएको छ जस्तो छ। नुवाकोट, काठमाडौँ, मकवानपुर, भक्तपुर, ललितपुर, काभ्रे पलाञ्चोक, रामेछाप, सिन्धुली भनेको यो सेन्ट्रल हिल्समा पर्यो, सेन्ट्रल हिल्समा पर्यो। त्यसपछि सेन्ट्रल प्लेन्समा हेर्नु त चितवन, पर्सा, बारा, रोहतक, सर्लाही, मत्सरी, धनसा, अनि वेस्टर्न माउन्टेन, त्यस्तै वेस्टर्न हिल्स, अनि वेस्टर्न प्लेन, अनि मिड वेस्टर्न माउन्टेन, मिड वेस्टर्न हिल्स, मिड वेस्टर्न प्लेन्समा बर्दिया, दाङ होइन, अनि फार वेस्टर्न माउन्टेन, हिल्स अनि प्लेन्स भनेपछि 15वटा जोनको लागि होइन, सबै चाहिँ के छ भने हाम्रो एभरेज भ्याल्युहरू गरेर, जस्तो कि यसमा हामीले राखेका छ होइन, अनि प्रत्येक जोनमा पनि हामी जान सक्नुभयो। मैले यसलाई एकछिन चाहिँ के गरेँ भने क्यान्सल गरेँ तपाईँहरूले अर्को देखाउनलाई होइन, सेयर एक्सचेन्ज गरेपछि त मैले जुनमा जाँदाखेरि पनि देखाउनु पर्ने होइन र ऊ पहिला चाहिँ अब त्यो खोलिहालौँ ल पकाउन है एकछिन के हुन्छ एकैछिन है त केही क्वेसन्सहरू क्वेरीहरू छ भने त्यो बरु स्टार्ट
यहाँ
गरौँ न
क्वेसन आएको छ सर एक दुईजना साथीहरूको
भनौँ न
पार्टिसिपेन्टहरू
भनौँ न
एकजनाले सोध्नु भएको छ do you also consider the flow of eroded material during high flood since bed load is the contributing a lot in raising flood in Nepal?
Yes, earlier I have said you that we have to consider the climate change effects, okay, because climate change is also occurring in Nepal, and saying that the flood quantity is increased in terms of meter cube per second, and that is not frequent but increased, and the sediment debris. And you see the guideline of Department of Roads at this time, they have prepared and said that you have to first define the design plot from different methods and select one of them which is giving the higher value, and then increase 10% for climate change, and then again increase 10% for sediment, okay? And then IRC is saying that for established calculation, increase the design flood for 25%. You see, so increasing, and it is making the established depth very heavy, and they are worried now. Department of Roads, the engineers are very much worried. Oh my God, this comes 40 meters of established depth, and that will of course go for 40 meters because you are using Lassie formula and all that. Because Lassie formula was developed for North Indian plain regions, and you are using in hills and mountains. And again, you are not accurately defining the particle size. Okay, so these are the problems. But I am very much positive to consider the bed load and suspended load at the time of flood, because in Nepal it is very much vulnerable, you see, and most of the bridges, especially bridge structures, are washed out or say failed due to not only due to the flood water, but with sediment also. But in this methodology at this time, I have not especially considered the debris or bed load. You see, so I think I think I have given the answer.
Yes, sir. Another question from Rishi is that I think this zoning shall be made to Thyssen area for each station rather than the district. So what response you want to give to this question?
Yeah, I have already mentioned. I have already told you that the best practice is use the data of rainfall station, individual station, and then making the Thyssen polygon, because isohytal is difficult. For isohytal, you need so many stations, and that is I think you can do for isohytal only for Kathmandu Valley, maybe for Pokhara Valley, not other places, because there are lack of stations. But Thyssen polygon, even only 3 stations you can find, even not within the catchment, out of the catchment, and you can make the Thyssen polygon and go for Thyssen polygon. Use the data, rainfall station data, which I have derived, and you can get the accurate result.
Okay.
त्यो मैले एउटा तयार गरेको थिएँ हैन अहिले ठ्याक्कै आइरहेको छैन, म यो देखाउँछु तपाईँहरूलाई। ओके, सो अहिले जस्तो कि
सर
अब
हाम्रो यो
मैले
प्रोग्राममा
मैले
हल्का
एकैछिन मैले
अपडेट
यो
गर्नु पर्यो। हाम्रो 2 घण्टाको प्रोग्राम हो, लगभग हाम्रो 15 मिनट मात्रै बाँकी छ। अब
ठिक
अलि
ठिक ठिक, मैले
एक्सटेन्ड गरौँ त सर? अझै के
मैले
छ
मैले होइन,
पार्टिसिपेन्ट?
पर्दैन एक्सटेन्ड गर्नु पर्दैन, म पनि
आधा घण्टा अझै
शान्तिपूर्वक
एक्सटेन्ड गर्न रिक्वेस्ट गरौँ सबैलाई के छ?
अरूलाई प्रब्लम छैन भने मलाई प्रब्लम छैन।
ओके,
अरू अरू
म एउटा
साथीहरूलाई
अनाउन्समेन्ट
प्रब्लम
गरिदिन्छु
छैन।
त है सर।
ल, आधी घन्टा नट मोर।
सर हजुर
आधी
त्यो
घन्टा
आफ्नो काम गर्दै गर्नु, यो स्लाइड गर्दा नि म चाहिँ
मैले मैले
I would like to
गरिसकेँ।
request all the program will be extended for 30 more minutes since PCJ sir gave very detailed explanation of both of the methods. So we kindly request your participation in for the next 1 hour. And if you guys, if the participant feel that they are unable to, so you can kindly indicate out of the Zoom, and we will not take any notice of that. So that's the announcement here.
Okay, so can I continue?
Yeah, sure.
Okay, so you see, the best methodology, for finding accurately the flood or design flood is find maybe only one station, no problem, only one station within the catchment, okay, within the catchment. But practically, you see, it is very difficult in Nepal or Nepalese case, because according to World Meteorological Organization, if you go for the guidelines or norms of networking of rainfall stations, we must have in Nepal more than 1,500 stations. So still we are lacking 2/3 stations. Okay, so we have only 400 stations. We need 1,500 stations. So this is a lack of stations, and that is why you cannot find even one station in your catchment. And then what do? You have to find out of the catchment, and that is also very far from your catchment. That is why hydrological zoning is required. That is why, because hydrological zoning means that you consider that in Elam district, the rainfall will be uniform everywhere. Okay, so here is Elam. You see, from where the monsoon enters. Okay, so Elam is most higher rainfall area, but our result is showing that Dhapa is more vulnerable than Elam, because the monsoon enters from Dhapa and going like this. You see, going like this. Okay, so the monsoon movement, we have to study the movement of the direction of monsoon also, and this will again dependent on the height of the mountains. Okay, leeward, if you remember, leeward and windward, sides of the mountain. There are so many factors. You see, the catchment characteristics. There are forests, or there are paddy fields, or there are residential areas. So many things. You see, so many things. And still, the hydrologists of all over the world are seeking this rainfall runoff relation. And there are so many models. But the problem is, every model will give you the different result. Okay, So maybe similar type, maybe similar type. So our goal is, our objective is to find the best solution for flood prediction in ungazed basins of Nepal. Okay, so you must be clear on that. We are not talking about the gauge basis. Okay, gauge basis, you have gauge data. You can go for upstream and downstream, say transposition or like that for bigger catchment. We are talking about the small catchment. Let's say 10 square kilometer, 15 square kilometer, 100 square kilometer, and not more than 1,000 square kilometer. Okay, so now you see we have 300 stations all over the Nepal worked out for modified PCJ 2024 and 100-year only. Okay, 100-year is worked out, and 50-year I have started 50 years, and that will take I think 3-4 months, and 50-year also I will be disseminating. Okay, so what I have said is there are 5 development zones distributed by King Mahendra at that time. Okay, so this is your Eastern Nepal, Eastern Development Region. Okay, and this is your middle or central development region, and this is your western, and this is mid-western, and this is far western. Okay, now every development region has divided in 3 zones. Okay, so this is mountain, and this is blue type hill, and this yellow type plain areas. Okay, so 3 multiplied by 5 is equal to 15 zones. 15 zones have been recognized at this time by me. Okay, maybe other people will not be say they agree with my say proposal or recommendation. So give your recommendation. Then, if you are not agree, then we have to find the solution. So I am giving not top to bottom approach. I am giving you bottom to top approach. Bottom approach is go for your catchment, plot your catchment in Google Earth or everywhere in map, and then find your station. You take secant polygon or IIHR, no problem, or arithmetic mean, and then take the coefficients for station and find the accurate result. Okay, but if you have say no time, or if you are saying that okay, my catchment is 100 square kilometers within Nuwakot district. Okay, then you can take only coefficient of Nuwakot. That is the hydrological zone. Okay, because you see modified Dickens or sorry Dickens modified CFTG pavilion was developed for whole India. You cannot believe that whole India, not only whole India. In Nepal, before say 100 years ago, most of the bridges were designed by Dickens method. This is CFTG pavilion, and sea value was taken just approximately about 1450, and yen was taken about 0.75, and there was no return period. But at this time हामीले के गर्नु पर्यो? अब क्वेसन एउटा के हुन सक्छ भने सर मेरो सिन्धु पाल्चोकमा पनि पर्यो अनि काभ्रे पाल्लाम चोकमा पनि पर्यो, क्याचमेन्ट त यस्तो हुन सक्छ नि त, क्याचमेन्ट त जिल्ला छुट्याउँदैन नि, हैन? सर नो प्रब्लम, तपाईले चाहिँ त्यो दुईटै जिल्लाको चाहिँ एभरेज भ्यालु युज गर्नु, अनि मानौ तपाईको अझै ठुलो क्याचमेन्ट भयो जुन कि के छ भने यो इस्टर्न माउन्टेन जोनमा फस्छ, हैन? भनेपछि तपाईले इस्टर्न माउन्टेन जोनको एउटा भ्यालु चाहिँ छ एभरेज गरेको भ्यालु, त्यो युज गर्नु। इस्टर्न हिल्समा हुनुहुन्छ तपाईले यो युज गर्नु, हैन? म पार्टिकुलर त्यो मेरो क्याचमेन्ट चाहिँ के भयो भने धनकुटा जिल्लामा पर्यो भनेपछि धनकुटाको इक्वेसन युज गर्नु। सो यो यस प्रकारले अब अहिले यसको भ्यालिडेसन बाँकी छ, किनभने यसलाई म अब मैले आफैले युज गर्छु, जुन ठाउँमा युज हुन थालिसक्यो, फास्ट ट्र्याकको अहिले गर्दैछौँ काम, फास्ट ट्र्याकमा यसको मैले युज गरिसकेँ, होइन? राम्रो रिजल्ट दिइरहेको छ, जस्तो कि बागमतीको चोभार मेरा उसको फ्लड फ्रिक्वेन्सी एनालाइसिस गर्दाखेरि 1300 को हाडाहाडीमा आइरहेको छ मिटर क्युब पर सेकेन्ड भने हाम्रो मेथडबाट गर्दाखेरि झन्डै 1553 आयो भनेपछि त ठिक आयो नि त उसको फ्लड डाटामा त अझै 20% त जोड्नु पर्यो नि सेडिमेन्टको र उसको you have to consider the climate change and फलाना होइन यसमा त अब त्यो सबै कन्सिडर गरेर मैले भन्दैछु नि त होइन so I think it will give a good result and now it is very easy to use because you have to just find the consistency. N is same for all the stations, that is 0.776 and by round offing it we can use 0.777 and it is very easy to remember also. But only the variation of C. Even you see this Manang district, yeah? Where is Manang? Manang is very much, this is Manang, you see? Where this Himal, where Manang? Manang, only C is 5. That means if from 1 square kilometer your catchment is 1 square kilometer, then your flood, 100-year flood will be only 5 meters cube per second. Only 5 meters cube per second. So now it is very clear that depending upon the location, depending upon the monsoon, depending upon the size of catchment, the modified PCJ 2024 has been worked out, very easy equation. And that's all from my side. If there are some queries, and then we'll talk about it. Okay.
Thank you, PCJ sir, for your in-depth discussion on both PCJ 1996 method and modified PCJ 1996. I think it will be really helpful for all the water resource developers in Nepal for the efficient design and cost-effective design of their hydraulic structures, and also to the bridge engineers, like I hope like their structures will be safe and efficient and cost-effective using PCJ modified PCJ 1996 method. And then our third session is the panel discussion session. So I'll also like to introduce all the panelists today before going to this session. First panelist is Naresh Wal. He is doing PhD at Louisiana State University. The second panelist is Khem Prasad Bhattrai. He is doing he is a PhD candidate at Colorado State University. The third panelist is Kamal Prasad Pandey. He is also a PhD candidate at ETH Zurich, Switzerland. And the fourth panelist is Ravi Mishra. He is a PhD student at IIT Dhanbad. And fifth is Pratyush Shah. He is MSc in IIT Roorkee and is a bridge expert in Nepal. And our last panelist is Rakesh Kumar Chaudhary. He is MSc from IIT Roorkee and is currently assistant professor at Thavthali Engineering Campus. So the discussion will go in this way. So all panelists will answer. Since we have very less time, so we'll only take one question. So all panelists will answer a specific question relevance to their field of expertise, because all of the panelists have different expertise in water resource engineering, and they will give the answer with regards to the topic that Dr. PCJ sir presented. And at the last, PCJ sir will summarize the responses from all of the panelists. So did you find this okay, PCJ sir?
Yeah, that's good.
Okay, so the first question is to Naresh Wal. So what do you think why this topic presented by PCJ sir is important to your field of expertise? Naresh Wal, please.
Thank you, sir, and thank you, Professor Dr. Premchandra sir, for sharing valuable insight and expertise in the design flood prediction for Orncase Basin of Nepal, which is very important for designing the different hydraulic structure. So to relate with my research, previously I was doing research in environmental flows, or we can say eco-hydrology. So in eco-hydrology, to restore river natural flow regime, peak discharge is crucial for maintaining the river ecological health, and natural flow patterns, which include variability in the flow rates and the timing of peak discharge, which support, we can say, diverse and dynamic ecosystem, which mimic the natural disturbance that many species, we can say salmon fish or other aquatic habitats, that have adapted to over time. So, country like Nepal with hilly and mountainous region where stream gauging is too difficult and costly, as mentioned by Dr. PC sir, and also hydropower is developing in rapid speed. So we can use this kind of method to get peak flood, or we can say peak discharge, to design environmental flow regimes that can mimic natural flow patterns, so that we can support the restoration of degraded ecosystem due to anthropogenic activities such as dam and river diversion project, to maintain the ecological integrity of the water process. So to know or to get the peak discharge or peak float, we can use this method in eco-hydrology, I guess. So this is my opinion. Thank you.
Yeah, thank you, Nareshwar, for your opinion. And the second panelist is Khem Prasad Bhattrai. So, Khem, what do you think that why this topic presented by Dr. PCJ sir is important to your field of expertise?
Thank you, Ishwar sir. And I would like to thank Dr. Prem Kumar Jha for this wonderful presentation and presenting his PCJ model. So I worked for some hydropower countries in Nepal, for some hydropower projects in Nepal before, and during that time I found that the way the hydrological predictions were made, um, it is not very very relevant, very reliable. So we have seen that hydropowers have suffered many disasters due to high flood, and we have also seen that some of the hydropowers have failed to meet the discharge, the power production that they have claimed. And in this case, it is very important that some accurate methods are applied for discharge and flood predictions. So I think PCJ method is very helpful if they can implement this method for discharge predictions.
Okay, thank you, K. Prasad Bhattrai, sir, for your opinion on this topic. And the third panelist is Kamal Prasad Pandey. So, Kamal, what do you think? Like, how much relevant is today's discussion to your field of expertise?
Thank you. First of all, thank you all, and thank you, Dr. PCJ, for great insight into the methodology. Yeah, also during the session, PCJ sir mentioned about the NUM, the place where I have also worked a lot, and as Dr. PCJ said, like the area is like showered by frequent different intensity of the rainfall. I worked in Upper Arun project a lot of time, so each day you would get like variable intensity of the rainfall, which are like short burst of shower. So uh, regarding all those my experience, I have to say that in Nepal, especially considering the local infrastructure development and big hydropower development, we have a threefold of problem. The first problem is you have to bring the access road, and for the access road you need a proper drainage, because it's mostly the hill area, and you don't have a lot of gauging station around, and you need to define the runoff for designing the bridges or culvert required to go to the access road. And the second problem is like, so for the hydropower developers, it's extremely important that they take in account for the discharge of the small stream and the catchment on the upper portion of the area where you don't have like the gauging station, then you have to make some prediction. And third one is like when you are trying to build a big hydropower, the challenge is always to provide the environmental flows, as Naresh said. So if you want to make some provision for the environmental flows, or if you want to design a fish passage and give it certain discharge, then you should be able to know like what are the expected peaks in the flow and how you can manage that, because most of the fish which are living in the fast flowing river, they tend to move during the peak flow. So if the peak flow estimation is good, then you can design a structure which you can design a holistic structure which can safely pass the flood, as well as you can provide some provision for the fish passage as well as the environmental flows. So these threefold problems we have mostly in the Nepal. They can be in some extent solved by using this kind of method during the planning stage. In the detail stage, you can like install the gauze and have the actual or real reading from the site, but beforehand you should know like what kind of situation you are expecting in those places. So this kind of method which are quick to implement are really useful in the project planning stage, and it's really helpful to design or robust project structure. So this is my outlook from all the things Dr. PCJ has mentioned earlier.
Thank you, Kamal Prasad Pandit, for your opinions. And our fourth panelist is Ravi Mishra. Ravi, what do you think that why today's, today's topic is important in your field of expertise?
Thank you, Ishwarji, for this question. And first of all, I'd like to thank Professor for his amazing talk on the regarding the maximum rainfall discharge prediction, especially in the Angos Basin in Nepal. Before me, like other three panelists, they have already mentioned how it is very much important, especially talking about the hydraulic structures or hydropower sector. I'd like to bring in a perspective from the sediment transport portion, where like as we all know, or as we might be familiar with that changes in discharge patterns or the discharge pattern in any of the rivers or they directly impact the reverse channel morphology and understanding discharge variations helps predict riverbank erosion from sandbars to channel adjustments, and also it is going to affect this hydraulic structures, right? Like scour around the structures. So high discharges may cause heavy scour, or in channels which are carrying which are heavy sediment laden, there might be heavy depositions. So understanding the or being able to predict the discharge also will help us predict such erosion and sediment transport processes. And this is going to definitely, with increased accuracy, we'll be able to design structures more economically and sustainably. So I believe that such methods are going to play huge role in the design. And one important question I had before was, if Professor he is interested in this, I would definitely like to ask him about has he ever incorporated the factors such as climate change while designing this method? Is there any variable which deals with the changing climate in this method? And if not, or if there is, like what further research efforts are needed to develop methods that are more resilient to climate change impacts on discharge patterns? If Professor is interested in this question.
Yeah, sure. I'll take a mark on that, and when I go back, Professor PCJ, then I will remind him of this question. That's really interesting. And then our fifth panelist is Pratyusha. Pratyusha, do you have any comments on or questions on comments on this? Pratyusha. Okay. I think Pratyush sir is unavailable at this stage, so we'll go to panelist 6, Rakesh Kumar Chaudhary. So Rakesh sir, what comments you have on this question?
Thanks. Thank you, PCJ sir, for your nice and wonderful presentation. I think it is very much interesting topics for the today's session. Initially, I have used during my bachelor project, fourth year project for hydropower, which I studied at IIHR campus. It was guided by Professor Raghunath Jha. At that time, it was very much tedious to compute the design discharge based on the PCJ method. We have to use the lot. We have to compute the lot of the factors, and but now it seems very easy. By joining it and providing C for various rainfall station, it seems very much easy. I have not used the modified forms, but I have used the previous PCJ methods for few bridges, and I have compared the results with different empirical formulas, and I found it comparable to others to others results. And I think we should have to promote these modified PCJ methods for various for the design of various bridges, and also I think we have to cooperate. We have to enhance this method to use in design for the bridges as well as for the irrigation structures. I think so. Thank you, sir.
Yeah, thank you, Rakesh sir. Thank you all panelists for your nice comments on this question. So, in summary, like all of the panelists, through the different expertise, they have uh, taken in the question of taken in the perspective of e-flow, fish passage, sediment transport, and also climate change impact, especially in regard to regard to modified PCJ methods. So PCJ, sorry. So PCJ sir, what are your responses to all of the panelists?
Okay, thank you, sir. I think we have extended much more time than
Okay.
we thought, but the topic is very, I think, important. Not only important, it's sensitive for Nepal. Flood issue is, I think, talked about this everywhere, because we have master degree in climate change. I think since 10 years, I think they are taking. But you see, when we go for thesis work or dissertation work for PhD, you see, nobody is interested for the solution of the problem. Nobody. I think even I'm not giving the say blame to only to the candidate forest. Even faculty, okay, even supervising faculty are not interested in solving the problems or say innovating new formulas and methodologies. Yeah. You see, behind this, the problem, the main issue is again government of Nepal, about leadership, about political leadership. Because you see, in I think you are also so many people are studying in US and Australia and India. Yeah? You don't have to pay for higher study. This is I would like to say this is illegal because this is a crime. You see, for higher studies, the government should pay, because that will be the research level, higher intelligence level, and there will be some research work for the country. But again, if I ask the PhD candidate in say our future campus that for whom you are studying PhD, and the answer will be for myself. Is that correct, Isha? So the main problem is, we are for me, For me, it was not applicable in 1993, 1996 also, because I was not doing my PhD at that time for myself. I was doing for that for Nepal Ama. And that is why I have discovered that methodology and used that methodology about more than 20 years. And now a time I felt that, okay, the data is also sufficient now. More than 300 stations can be worked out. And I found the time. There you see, if there will be a will is more important. Then you can do all things. Okay. So I think our panelists are very, they have raised or commented very good things. So again, I think climate change should be considered, but there are so many studies research. Maybe I think more than 20 dissertations, PhD dissertations, and more than 50, say, MSc theses are for the climate change thesis. But no one thesis can say me that, okay, for climate change, monsoon time, for this return period, you have to increase the design flood by this coefficient. I need that. But I'm not going to discover that because that is not my job. Okay? That is beyond my job. That is beyond my research. A climate change expert must give me the coefficient. Okay, sir, for 10-year return period, the value should be increased like this. The 100-year return period you should increase like this. Or what we have talked about this, say, regional zoning or 300. You should give me all the stations, 300 stations. Give me the climate change effect on monsoon. Maybe somewhere it will be decreasing. Maybe somewhere it will be 1.05 coefficient. Maybe somewhere it will be 1.2 coefficient. So I'm not going to do that. Okay. Regarding environmental flows, environmental flows is very important in Nepal. And in most of the projects I was working for hydropower irrigation, all these projects are considering environment flows, and that will be 10% to 25% for conservation areas of the minimum flows, minimum monthly flows. Okay, minimum monthly flows will be either in March or April or maybe somewhere in February also. Okay, so the flood is not important for the environmental flows. Okay, in that sense, that we say that environmental flows, ecological flows, or there is another one word also. Okay, so but if you consider that the environment will be damaged or say if affected by the flood, then of course it will be important. Okay. Now the sediment and debris. Of course, in my mind, you see when this East-West Highway has ADB project that is going to widen all the 1,000 kilometers east-west. Okay, by four lane. And I was engaged from Kakadvita to say Naranghat, up to Naranghat. 3-4 packages. I was just engaged in that in the IIHR. Yeah, okay. And I raised the question because as you saw that in my recommendation at that time in 1996, that highway should be designed for 300 years return period. Okay, the drainage. Okay, but we have designed for 100 years only. Okay, and culverts we have designed for 50 years only. So that is decided by economical consideration. Okay, and I have already said that the DOR is not serious. Not serious about this because I have talked so many times that you have to classify all the roads and structures, and then you have to decide about the return period. It is not good that even village road bridges you are designing for 100 years, and railway bridges also for 100 years. It is not good. So I have already said them, and maybe near future they will be accepting this. Okay. So, but in my mind, from earlier side, and when we go for this widening of highways, there were Korean consultants, and I took this thing, and they said that okay, it is good to consider the debris and sediments, all that, but that will be again increasing the flood, and that will increase the business fund. So again, economic effect, and and okay, no problem. Then I just decided that okay, so big rivers such as Koshi, Kamla, Bagmati, Narayani, all these big rivers should be at least designed for 300 years. But again, by say motivating them and all this, because our officials were also not ready for that. But these bridges are now designed for 200 years by my forceful request. By my forceful request. So when you increase this start, then the sediment, all these things, climate change, all will be coming on that. There is no any equation, or there is no any model which will 100% accurately give you all these things. Okay. So I think I have addressed, and fifth passage. Kamal is very much, I think, right, that fifth passage structure, we have just, if you remember, we have gone to Bagmati. Just I have 1 month ago gone to Bagmati with my students, and they always ask, where is fifth passage, where is fifth structure, and 20 years, about 20 years, I am lying that okay, fifth structure is there but not working. because maybe the design was not appropriate, or the construction was not appropriate. So again, if the flood flow is important for this passage structure, then it should be defined accurately. And at this time, we have 2 master degrees, water resources and hydropower, and we have provided 1 elective from hydro lab. Ishwar knows that. So from hydro lab, Umesh Singh and others will be taking, I think, fifth passage structure, fifth passage structure, and like that. There will be design also, and so we are moving. But Institute of Engineering, Tribhuvan University, even is not capable to doing researches individually, because no funding for researches from government of Nepal. And even you see, it's sorry to say that, but I'm very much unhappy that my students are paying 5 lakhs for doing PhD in Pushok campus. It's not good investment, you see. That is why I'm not so much interested for say doing this PhD thesis or all that, because the students are also not very much eager to develop some new things for Nepal, and the faculties are also like that, and the leaders are also like that. So just for me, it's important that I have to develop again more and more, considering climate change, considering say debris, all these things. This is a modified. Now again, maybe revised about 4-5 years. I think after my retirement, let's say that up to 2030, we can. This is my dream, that we have to develop. Maybe IIHR will be helpful with me. So develop a software. So this software will ask you the coordinate of your catchment, the center point of your catchment, or the outlet point of your catchment. Give you the coordinate X and Y, and nothing to be done, nothing. And the computer program will search itself in Google Earth or in GIS this, and find the catchment area, find the other parameter which we say modify later, and give you the expected which return period do you want, and then you can give, okay, 100 years, give me the result. That will give you, okay, 100-year result. Catchment area 5 square kilometer, below 5,000, 5 square kilometer, above 5,000, 1 square kilometer, and this is your flood result considering the climate change and debris and all of that. This is my dream, that after 5 years there will be a software, PCJ method, whatever it will be, maybe other name, I don't know. But my dream is within 5 years, you have to develop a software that will promptly, that will instantly give you the result anywhere in Nepal. Thank you very much, all of you, listening my presentation. And if you are interested, then already in Kathmandu, we have book irrigation and drainage engineering third edition, where I have provided this modified PCJ 2023, all the results. But in paper terms, I think in research date, PCJ 1996, I have just put, I think, 3-4 months ago. And now I am preparing this PCJ 2023 paper, and that will be also, I think, posted maybe within a month at research date. Okay, so you can use this method, and even if you are not satisfied with this method, you can use this method for the comparison purposes, because the results you recommend for the design of the structure is totally dependent on you, because you are responsible. You are responsible for the, because we also ask, and other also ask, why you taking this method and why not this method? And then you have to give answer, okay? The best answer for my method is that it is rainfall-based method, and for Nepal, where data is very much unrealistic and unavailable, the result is in safe side, and that is why we can use this method for being the expert. Expert should be must be in safe side. You see, you go for the cost. You go for the cost, but you must be in safe side. But the DOR or other officials of Nepal government, they are not serious about this. They are only thinking about the money. That is not good. We must save our people. You see, what is the accident rate now at this time in monsoon? Okay, thank you very much. And if there will be need of any that type of presentation, I will find time for you. Okay, thank you, IIHR.
Yes, sure. Thank you, PCJ sir, for your for summarizing the views of our panelists, and they were really insightful. And also, we got a new research direction from you on the development of software. So we'll take note of that. Our IIHR founder member will be really excited and will be motivated to do some research on that also. And at last, I'm going to close this session now. Thank you to all of the participants who participated in this webcast. Special thank you to Dr. Prem Chandra for his enlightening presentation on a rainstorm design flood prediction for Angad Basin of Nepal by modified PCJ 1996 runoff model. Your expertise and insights were really invaluable for us. And to our panelists, thank you for enriching the discussion with your thoughtful perspective in your with regards to your expertise. Your contribution greatly enhanced the depth of the conversation. And at last, like to our participants, your engagement and attention throughout the webcast have made this event a success. We are grateful for your time and participation. Your questions were also really insightful, and that enhanced the discussion given by Dr. PCJ sir. And thank you very much all for attending this webcast. Thank you very much. And I close this session. Okay.
Okay. Thank you. Thank you,
Yeah,
sir.
we can turn off the recording now. Yeah.
Hmm.